All right, so let's continue with error detection and correction. EDC, error detection and correction bits, for example, redundancy. So you repeat actually some of the input and extend the site. This way, with this extra redundant information, we can detect errors and sometimes correct them. So here, D is the data protected by error checking, may include header fields. So this is D, and EDC is the error detection and correction bits. So during this transmission, the other part receives something, so they have to check if this data contains any errors. So in order to do it, they also calculate this EDC and check if they match. If detected error, you have to, if you can correct them, you correct them. Otherwise, you have to ask for retransmission. But of course, error detection is not 100% reliable, right? Because if there are many bit errors, then you cannot detect it. Protocol may miss some errors, but rarely. Larger EDC field yields better detection and correction, but of course, this increases your bandwidth, so you have to find a good error correcting code. So single bit parity is very simple, detect single bit error. So when you have this kind of data, you just XOR all of them and actually determine if it is odd or even. So you write the result as the parity bit here. This is very common in communication, the parity bits. Even parity, set parity bit, so there's an even number of ones. Okay, but this can only detect one bit error and cannot correct it. So we should have something better. You can do two-dimensional bit parity. In this case, you can detect and correct single bit errors. Idea is to write as a two-dimensional matrix, right? Then write the parity of rows here and parity of columns here. Now, if you detect an error at if there's an error at a single bit, from this parity and this parity, you can detect it and then correct it, right? So in the case of no errors, it will be something like this. So in this case, you can detect error and correct it, right? So internet checksum, we talked about this before. Goal is to detect errors, in other words, flip bits in transmitter segment. Sender treats contents of UDP segment, including UDP header and fields and IP addresses, as sequence of 16-bit integers. Recall that in this internet checksum, we added these 16 bits values, not XORed them, but added modulo 2 to the 16. Checksum value put into the UDP checksum field. Receiver compute checksum of received segment. Check if computed checksum equals to the checksum field value. Not equal, error detected. Equal, no error detected, but maybe errors nonetheless. So for this reason, in this layer, we have Cyclic Redundancy Check, CRC. More powerful error detection coding. So your data is D, and we generally think about it as a binary number. G is the generator bit pattern of R+1 bits. Okay, so you choose some G, and in the RFCs, in the standards, you can see this kind of G for 8 bits, 16 bits, and 32 bits. Okay, so idea is as follows: you have the data, and you provide R bit cyclic redundancy check bits. So how you add this R is actually you divide this data by G and write the remainder here. Okay, here's a formula, but we will see a basic example here. So choose R CRC bits, capital R, such that they are exactly divisible by G modulo 2. Receiver knows G, divides DR by G. If non-zero remainder, error detected. Can detect all burst error less than R+1 bits, widely used in practice like Ethernet or Wi-Fi protocol. So here the idea is as follows. Sometimes errors happen rarely, like in 1 bit and maybe later on. But if there are bursts of errors and the electromagnetic fields, this kind of things happen. Idea is to detect, up to R+1 bits. This is why you choose this R bits accordingly. Okay. So here's an example. You have the G in this example like this. This is your data D. So you add 2 to the R bits to the end, and you start dividing it, and write the division to the top, but the remainder at the bottom, and this is your R, cyclic redundancy bit checks. So this is how it works actually. So I'm not going to talk more about it, but this is the link layer error detection and correction.